Alright, I messed up on the recording. I had it muted. So we gotta reread it. Alright, the Hittites Dynamic Braking Unit BRD Series 200 volt class and 400 volt class operation manual, contents unpacking, inspection, importance notice, installation, wiring function setting, 4.1 notice, 4.2 functional setting, 4.3 example external connection, 4.4 example external connection, parallel connection operations, 5 troubleshooting, alarm contact activated with the inverter stop, 5.2 inverter trips with a 0 voltage during inverter deceleration, 6 pre-start checks, 7 inspections, specifications, 7.1 standard specifications, 8 internal circuits, 9 selection dynamic braking unit discharge resistors, 9.1 braking energy without the dynamic braking unit, 9.2 using the dynamic braking unit, 3 general formulas using for estimation, 10 maintenance and checks, notices on maintenance and check items, 11 parts order inquiry and appendix. And then we'll skip this one and the revision sheet. Alright, safety precautions. Carefully review this manual, author, and precaution document if they came with the dynamic braking unit with the insulating, operating, maintaining the unit. Familiarize yourself with the drive device specifications, safety precautions, handling, operating procedures. Review the device correctly. The manual with the two symbols of the first inform of the malfunction single indicate with the danger of the personal injury, property damage. Danger. This safety reminder indicates potential life-threatening situation. The instruction of the not filed with a serious injury, extreme case of the death that could occur. Caution. Safety reminder indicates potential danger to body and property with the unsafe instruction not filed with a minor serious injury and/or property damage could occur. Be sure to follow the instruction carefully. When you see these symbols, always read the following instruction notes and remarks. Installation caution. Mount the dynamic braking unit with a fireproof wall, metallic wall, or fire may occur. Keep the dynamic braking unit away from the possible flammable materials for fire may occur. Never hold dynamic braking unit with the front cover with wind carrying it. It could fall and injury could occur. Never allow any wire to dust, welding, spatter, iron fillings, or other material to get in the unit or fire may occur. The dynamic braking unit is very heavy installed with the unit with a solid ridge wall strong enough to support, otherwise it could fall and injury may occur. Do not use the inverter partially damaged, incomplete, or an injury may occur. Avoid any dangerous environment. Do not place dynamic braking in a hot, damp, wet location. Do not use the dynamic braking in presence of the dust and corrosive gases, explosive gases, flammable gas, oil, mist, or salt to keep the dynamic braking unit with the direct sunlight. Danger. Always connect with the grounding wire with the dynamic braking to prevent electrical shock and fire. All wiring should be done with a qualified electrician. Electrical shock fire may occur. Before wiring, make sure the supply power is off. The positive and negative voltage is 45 volts or less to prevent electrical shock with the fire. Always install the dynamic braking unit with the wall before with the wiring to prevent electrical shock and personal injury. Be sure to provide thermal relay with the circuit shut off the primary power of the inverter to prevent burning out of the external resistor due to the overheating. The dynamic braking unit malfunctions. For actual connections, see 4.3 and 4.4. Caution, make sure the voltage rating the dynamic braking is equal to the inverter to prevent the fire and personal injury. Do not cover the resistor direct. Do not connect the resistor direct with the DC terminals. Positive and negative fire may occur. Tighten screw with the correctly specified torque table on the make. Make sure every screw with a firmly tightened or fire may occur. Power cable for the should be MLFC. Flame retardant poly flexible wire allowing voltage 600 volt capable with a specified amperage fire may occur. 3. Control and operation. Danger. Be sure the front end of the cover dynamic braking unit is attached before turning on the power. Never remove the cover with the dynamic braking unit. You may receive the electrical shock. Do not operate with wet hands or you may receive the electrical shock. Never touch terminal dynamic braking unit while the unit powers on. Even when the unit has stopped, you may receive an electrical shock. Never touch any part of anything with the dynamic braking unit while the unit's power is on. You may receive an electrical shock or cause fire. Caution. Heating, radiating fins of discharge resistor during use of hot and cause burns and do not touch. Maintenance, inspection, and part replacement danger. Be sure to turn off the supply power. Make sure the DC voltage between the terminal positive and the negative is 45 volts or less. Otherwise, you may receive a serious electrical shock. Only authorized electricians are allowed to check the maintain and replace part with the dynamic braking unit. Take out the metallic accessories such as watch jewelry before operating and use insulated tools. Otherwise, you may receive serious electrical shock or personal injury. Appendix. Danger. Never alter and modify with the dynamic unit. Improper servicing may cause electrical shock or personal injury. General notes. For simplicity, figures the illustration on this manual shown without the cover of the peripheral parts of the device. Be sure to remount with the cover to other safety features before running the dynamic braking unit. 1. Unpacking the inspection. Handle the product with care with unpacking. Do not use the excessive force impact with vibration on the package. Check the following: package damage occur with the delivery, mail name of the voltage, etc. Order confirmation list accessories, including operational manual. Important notes for the note: the following improve the performance, safety, the operation of the dynamic braking. Never danger. Never alter the modify of the dynamic braking unit. Improve improper servicing may cause serious electrical shock and personal injury. No, do you use the BRD E2 E2Z breaking into the combination earlier version of the operating voltage of the terminal configuration directly may cover the dynamic units to malfunction. The set of the dip switch connection wires correctly with the setting and change of the operation voltage of the running device with the parallel connection. Be sure to turn off the power to dynamic braking units before DIP switch and connecting wires. For more information, wiring function setting, check wires connections carefully. If you correct them, you can turn the power to the inverter. Installation caution: mount the dynamic braking unit with a firewall-proof wall. Metallic wall fire may occur with the dynamic braking unit all away with a combustible flammable material solid may occur. Never the whole of the dynamic braking unit front cover while carrying it. It could also cause injury or could occur. Never allow any of the wires, dust, welding, spare the iron fillings, or other materials to get in the unit. The fire may occur. The dynamic braking unit is very heavy. Installation unit with a solid rigid with a wall strong enough to support. Otherwise, it could fall. But the injury may occur. Do not use the inverter partially damaged and complete with an injury may occur. Avoid any dangerous environment. Do not play with the dynamic braking unit in a hot, damp, wet locations. Do not use the braking unit present dust with the corrosive gas, explosive gas, flammable gas, emits oil, mist, or salt. Keep the braking unit out of the direct sunlight. To ensure ventilation, mount with the dynamic braking unit wall with at least 10 centimeters clearance above and below the unit with at least 5 centimeters clearance at left of the right side of the unit, shown in figure 3.1, 3.2a, and 3.2b. Do not play with the dynamic braking unit. Ventilation openings on the left of the right horizontally required clearance surrounding the dynamic braking unit. Shows 10 centimeters by 10 centimeters or more. Never play with the dynamic braking unit with a ventilation opening face left and right clearance around the dynamic braking unit. E2 30k, 55k, and EZ2 55k, 110k. Shows figure 3.2 show the clearance around the dynamic braking units. EZ2 30k horizontal installation 5 centimeters, 10 centimeters or more. Vertical installation 5 centimeters or more, 10 centimeters or more. Wire function and settings. Wire notice: danger. Always connect with the ground wire with the dynamic braking unit to prevent electrical shock. All wiring should be done with a qualified electrician. Electrical shock may or may occur. Blue wiring: make sure the supplier power is off the pot. The negative voltage is 45 volts or less. Prevent electrical shock or fire. Always install the dynamic braking unit on the wall before wiring to prevent electrical shock and personal injury. Be sure to provide thermal relay circuits to switch off the primary power over the inverter to prevent the burning out of the external signal resistor doing to overheating dynamic braking unit malfunctions. The actual 34345. Caution: make sure the voltage rating dynamic braking is equal to the inverter. Prevent the fire and personal injury. Do not connect resistor routed directly with the DC terminals. Pop with the negative. Fire may occur. Tighten screw with the core correctly specified. See the table to the right. Make sure every screw with a firmly tightened fire may cause. The M3 screw size 0.6 to 0.9 newtons of metric. M5 3.8 to 3.9 newtons a meter, M8 110 to 13.5 newtons a meter, M10 21 to 28. Power cables should be MLFC, flame retardant polyflexible wire allowing voltage of 600 volts capable of specified amperage. Fire may occur. Note to be sure to provide alarm contacts, alarm 1 and alarm 2 with a trigger that will shut off the primary power of the inverter, prevent overheating, burning if the dynamic braking unit malfunctions. Use cable specified rating short possible to 5 meters between the dynamic braking unit inverter, positive and negative up to 50 meters between the dynamic braking unit discharge resistors. P and RB up to the 5 meters with the EZ2 with the 30k. Always make the wire connections as short as possible. Not loop extra cable. Example: the correct wiring inverter up to 5 meters. Dynamic braking unit up to 50 meters. Up to 5 meters. Discharge resisting. EZ2 30k system cable to the dynamic braking unit and the discharge resistor must be 5 meters or shorter. Example: incorrect would be the inverter, and then the conduction of them would be dynamic braking unit, induction resistor. Cable must be tied together supportably, firmly, no excessive load on the dynamic braking. Parallel connections interlock with the function U with the single cables MA and MA2 and LSL and SL2 between the dynamic braking unit must be more than 5 meters of the length, no more than 75 hundredths of a millimeter, 2-inch width of the section area with a single cable that must be fully separated with the main circuit cable. Choose main circuit cable to 10 centimeter or more from the signal cable. When combination various resistors with the induction of the resistor may raise the shear voltage during the switch operation to prevent use of the larger cable to otherwise twist them. Always use the top 6 non-induction resistors, signal resistance to the insulated crimping terminals to connect cables to the terminal board TM1 or TM2 with the EZ2. Use the closed loop terminals insulated caps to connect cables to the terminal board TM2 and TM3 of the EZ2. Functional setting, you can select the main unit of the sub-unit operating voltage level of the dip switch. Note, be sure to turn on the dynamic braking unit with the setting of the dip switch. Open voltage setting changes function. Dynamic braking unit supports 3 operation voltages. Standard factory set 5% and 10%, negative 10%. Select the operating voltage by setting the dip switch. If the over voltage trip to occur with a certain voltage deceleration time, the function reduces the operating voltage. Dynamic braking preventing the over voltage trip. However, the high voltage input voltage only with the power will determine the brake unit, determine the operating voltage level according to receiving voltage. Receiving the voltage by 2 by the 20-volt opening voltage. Parallel connection interlocking function. You can run 2 parallel connected dynamic braking unit interlocking connection, 2 signal wires, MA1, MA2, SL1, SL2, the setting of the dip switch. You can use the 1 dynamic braking unit, the sub-unit allowed to work with the operating voltage main unit setting dynamic braking unit as a sub-unit by dip switch. Show the setting of the dip switches and functional operation voltage dip switch setting. X is any position remarks in factory set. Main unit operating voltage standard 363 volts or 725 volts off, on, in any position. Main unit operating volt, and that has a factory set. Main unit operating voltage negative 5%, 345 volts, 689 volts. Your dip switch settings are on, off, and on in any position. Main unit operating voltage negative 10%, 326 volts, 653 volts, on, in any position. Subunit is X off and X, any position off and X. Their operating voltage correspond with the main unit value with parentheses that indicate the operating voltage of 400 volt class dynamic braking unit. Example, external connection. Show the example of the connection for the motor control circuit containing only 1 dynamic braking unit over the discharge resistor equal to more of the resistance specified. If the resistance is insufficient, the dynamic braking unit may be damaged. Prevent overheating, burning due to the malfunction of the dynamic braking device with the circuit shut off the primary power inverter connection. The circuit alarm contact terminals alarm 1, alarm 2. 4.2 show the connection of the thermal relay. 4.2 show the list of the applicable. Give your 400 volt class with the 200 over 220. 50 to 60 hertz, 60 hertz and power supply. MG battery switch, BSS. Goes through 2 switches, then a switch to the relay with a main relay motor 76.1. And from the 2 motors, it goes in alarm 1, alarm 2, which goes in the dynamic braking unit, main unit, which has a resistor breaker with the external resistor and thermal relay, M1 and A2, and a ground, a positive, and negative terminal, motor, TO, and the terminal and relay terminal to the EF capacitors, which go on the MG with the inductions, and then they show the 200 volt class, which is slightly different, which show the TO, RO. And show the external connection. Example 1. The dynamic braking unit shows positive resistor. The terminal external with the resistor with the 3 elements. 3 relay used to dynamic braking positive, and then to the terminals external with the resistor 2 element. 3 terminal 3 relay used. Example external connection, parallel connection operation, figure 4.3 show the connection external with the motor control system which achieve the parallel connection interlocking function. In this case, both of the main unit sub-unit may be external resistors of the same resistance. Prevent overheating, burning with the dynamic braking unit, malfunction, provide a thermal relay to shut off the primary power with the inverter with the thermal relay operating. Figure 4.3 show the connection thermal relay. Table 4.3 show the list of applicable wires. Basically the same except for MA1 2 goes to the dynamic braking unit sub-unit, which has the alarm 1 and alarm 2 still connected in the same loop, which goes past the relay and main generator, MG. Then the thermal relay, there's 2 thermal relays, 76.1 and 76.2 with the external relay, and 2 positives and a negative for dynamic braking unit, which go to the positive and negative. The negatives go to the negative of the inverter and the positive of the inverter. The motor has these RSTUVW, which go to the ENF capacitors, and then 200 volt class. 4 2 applicable wires. Model common resistance wire resistor P and RB and positive resistor RB connections. Note 1 SL1 SL2 MA1 MA2 and ground wire 200 volt class E2 30K 55K 400 volt EZ2 30K 55K and 110K. Alright, we're troubleshooting. Alarm contact is activated with the murder stop of the event with a maybe cause of a large amount of regeneration energy frequently breaking with the result of the overheating discharge resistor. Prevent its event. Check for the correct resistant discharge resistor for the number of the dynamic braking units used in decelerating time. The event is also clear with the incorrect connections made with the voltage and appropriate. Follow the instruction below to check the repair. As the alarm contact is working, the resistance is in specified range. No. Check for the correct resistance. Yes. Is the dynamic brake connected pair well? If no, then the running indicator event even while the inverter is not decelerating slowly and standby. And then we'll read in the no, the TM is greater than TM3, less than wire connection. And then no, go to correct wiring. And if yes, go to the dynamic braking unit is faulty, repair and replace. Remember, if your dynamic braking units are connected pair well, yes, do not run indicator main subsidiary units for the during deceleration inverter. No, check the wiring of the main subsidiary unit, the dip switch setting for use of the subsidiary units. If the running indicator's main subsidiary units turn on during deceleration of the inverter, yes. Is the main resistor disconnecting main subsidiary unit? Yes. Believe the disconnected resistor of the maximum resistance? No. If the running indicator event with the inverter is not decelerating, accelerating, or standby? Yes. If the receiving voltage is higher than the rated voltage 10% or more? Yes. Correct the incoming voltage? No. If TM is greater than TM2, the wiring of the SL1, SL2, MA1, MA2 connection not required the dynamic braking unit. Used alone? No. Correct the wiring? Yes. The dynamic braking unit is faulty, repair and replace. When the inverter is tripped over voltage during the inverter deceleration, the event is caused with too much regeneration energy, which is unable to handle the increased voltage to prevent problems. Check for the correct resistance with the discharge of the resistor. Normally, the dynamic braking unit deceleration time problems occur. Also, the decharging resistor disconnected with the wire connections made with the dip switching setting is properly followed with the instruction below. The inspect with the repair. The zero voltage trip to do with the run indicator returns the deceleration inverter. No, the runoff of the indicator may unit the off signal used for the dynamic braking unit. The dip switch setting is for the subunit correction. Connect with the dip switch setting with the subunit. Yes, even the positive negative TM1 do correction. If no, connect the correct connection. If yes, dynamic braking unit is faulty and replace it. Run indicator turn on during deceleration inverter. Yes, check with the corrective deceleration discharging resistance. Discharge auxiliary may be disconnect. Alternatively, increase deceleration time. If the run indicator main off signal used for the dynamic braking. Yes. Is the dip switch setting of the main unit correct? No. You connect with the dip switch setting of the main unit. Yes. The PN connection TM1 TM2 connection correct? No. Correct the connection. Yes. The dynamic braking unit is faulty. Alright, pre-start and check the following safety instruction below before operating device. Danger, be sure the front cover of the dynamic braking unit is attached before turning on the power. Never remove the cover of the braking unit with the receive of the electrical shock. Do not operate with wet hands may receive the electrical shock. Never touch terminal of the dynamic braking unit while the braking unit power is on. Even when the braking unit is stopped and you may receive the electrical shock. Never touch any part of anything of the dynamic braking unit while the braking unit power is on. You may receive the electrical shock or cause fire. Caution, heating radiation from the discharge resistors during the use of the hot and cause burns and do not touch. Note, check the wiring of the connections. Wrong wire, incorrect connection may cover the dynamic unit to the malfunction or cause damage. Check if the non-ground terminal has been used. Grounding non-ground terminal may cover the dynamic braking unit to malfunction. 3. Check with whether the foreign material, wire, dust, crimping terminal tool, or etc. in the dynamic braking unit. Foreign material of the dynamic unit braking unit may be caused short circuit units of the causing the malfunction damage. Check with the short circuit. Inspect with the ground fault. The dynamic braking unit may cause malfunction or cause damage. Alright, 7 specification. Standard specification table 1, 7-1 show the standard specification of the dynamic braking. However, you the specification, if any, should be preferential, and standard specification show the model EZ E22 30K 55K EZ2 30K 55K show the enclosure voltage open type 40 voltage class 200 voltage 400 volt class operating voltage 362.5 plus or minus 5 volt 355 plus or minus 5 volts. And then for the 400 class, 725 plus or 5 volts, 710 plus or 5 volts. Standard status light indication on. Discharge resistance 1, 4 ohms and 2 ohms or more. 1/5 of the allowable operation system continuous on time, 2 minutes maximum. 400 class have the 10 ohms or more, 600 ohms or more, 3 ohms or more with a tenth and a fifth and a tenth a second and a 2-minute maximum. Discharge resistant 2, 6 ohms, 4 ohms or more, 24 ohms or more, and 12 ohms or more, 6 ohms for 44 volt, 400 volt class. For both 200 volt and 400 class, all is continuous positive protection function and protection of the power modules against overheating. Thermal relay protection operated with a cooling fan temperature of 100 degrees Celsius, usually covered by B contact rating, 200 volt AC with a 3 amperes resistor load, or 2/10 of the amp L load, 36 volt DC with a 2 amp resistor load, and maximum load of the 115 volt DC 500 milliamps or resistor load, ambient temperature 10 to 50 degrees Celsius, storage temperature 10 to 60 degrees Celsius, negative 10 to 60 degrees Celsius, relative humidity 29%, non-consenting, vibration 4.9 meters a second at 10 to 55 hertz. And that's closed. It's installation site up to 100 meters of sea level, indoor with corrosive gas and dust. Coating color Monsol coloring system 5Y71 aluminum coil fin is not coated. Others equipped with a parallel connection interlocking function main and subsidiary unit. Show the model BRD EZ 30K type HP form DM operating voltage 725 plus or minus 5 volt 2 kilograms, and then show the grounding terminal of the M5 screw and T terminal with the width of the 6 of the M3 screw, with the T M terminal with the screw width of the 13 of the M5 screw. Model of the BRD E2 30K and EZ2 55K both have type HP and DM. Operating voltage for the 30K is 362.5 plus or minus 5, weight at 6 kilograms. 725 plus or minus 5, 6 kilograms. Show the mounting and the ground terminal of the M5 screw. TM1 terminal with a 0.4 M3 screw. Note, leaving the terminals 1 and 2 of the disconnected TM2 terminal with the 23 M8 screws, negative resistor, and TM3 terminal 5.9 M3 screw, alarm 1, alarm 2, dimensions in millimeters. Model BRD E2 55K and 110K type and form HP and DM operating voltage 362 plus or minus 5, 725 plus or minus 5, 8 and 10 kilograms. Shows technical TM1, TM3, TM2, ground terminal M5 screws. Alright, internal circuits. Internal circuit with dynamic braking E2 30K, 55K, EZ2 30K, and EZ2 55, 110K. Or respectively figures 81, 83, and figure 4344 show the connecting terminal with the E2, 30K, 55K, EZ2, 55K, 100K, with terminal board 1, MA1, MA2, SL1, SL2 control signal with permanent parallel intercanal connection, TM2, positive DC voltage, PMRB resistance, negative DC voltage, negative TM3, alarm 1, alarm 2, alarm contacts, terminals, EZ2, 30K, terminal 1, terminal 2 with the MA1, MA2, SL1, SL2 control signal parallel interlocking connection, AL1, AL2 alarm terminals, TM3 positive P DC voltage positive PRB resistance negative DC voltage actual terminal layout screw size figure 71373, and then shows a large. We'll flip it around and look at it real quick. I'll see if you can follow me on these. These are actually pretty large. Alright, so over here you have the resistor, RPs, resistors, capacitor, OP1, resistor 6, 7, and 8, and 9, and then capacitators are the lines, PSM board, looks like a saturated coil, but the DP, oh yeah. This is a saturated core PSM, capacitor resistors for the saturated core. And then it has a DIP switches, which are 1, 2, and 3 resistors, and show the resistor capacitor, a transducer, or an amp and or gate, which is the triangle, and then the capacitors PC1, PC2, resistors, diode, yeah. Actually, these are kind of hard. I'm gonna make my own I'm gonna do my own dynamic braking view pretty soon. I'm gonna do my own deal of dynamic braking. Flipped it the wrong way. Alright, selection of dynamic braking is discharge resistors. The synchronized speed of the motor decreases with the relative degree to set frequency happens with the synchronized speed of the motor is less than the rotational speed of the rotor. Slip becomes negative, consequently the torque generated by the motor operates with the braking torque. The braking torque is a function of voltage versus frequency. For example, the difference between the torque at frequency F1 and the torque at frequency F3 is a figure 9.3 caused by the difference between the voltage versus frequency ratios. Show the torque frequency speed curve at the frequency F2, torque feed frequency F1, torque feed speed curve at frequency F3, and then show the frequency change of the motor over the speed. 9.2 voltage versus frequency characters, output voltage over the frequency A and B, frequency F2, F1, F3. Instead of the motor operates generated the rotational energy of the motor with the converted electrical energy feedback of the inverter circuit, the figure 9.3. Show the power supply capacitors on the outside and converter selection DC smoothing section inverter circuit. Show the capacitor between positive and negative. A resistor, two transducers with the same base. These are ran parallel connection with the capacitors with and motor regeneration energy. The positive and negative between on the outside of the capacitors run to the dynamic braking unit and the discharge resistor. Regenerated energy stored in DC bus circuit is of the inverter capacitor feed type back. Alright, 9.1, braking energy without dynamic braking. Usually the braking energy of the motor with the sum of the motor loss include mechanical loss, inverter loss, overall efficiency, inverter control, motor with 65 to 90% of the depending on the motor capacity, the power loss of the braking energy fluctuated 10 to 35% when at the frequency of 50 Hz, 60 Hz. Shown with the braking torque up to the 111 kilowatts with up to 20% of the rated torque with the motor generation energy is greater than braking energy capacity for the DC bus circuit. It will be discharged and increase the DC voltage. This may cause overvoltage protecting the circuit shell, but the output of the inverter of the motor runs free. The dynamic braking unit for the load that has a high inherit of the motor with a decelerated unit with the dynamic braking unit will be needed to absorb resulting regeneration energy of the 9.3 with the voltage DC circuit retreats its present value of the transistor. Switches resistor RB comes with the regeneration energy of the heat. Instead of the V and F characters of the inverter, the permissive current with the determinative resistance of RB, the capacity of the RB, and the dynamic braking unit will determine the braking torque because the torque is generated by the motor depending upon the current passing torque. Transistor and resistor RB do not combine with the items of the blank tables of M1 and M3. For you, the dynamic braking unit, table M1 for the single braking dynamic unit, you see common conditions of rotational speed, the TB of the time. The BRD is the operational function for the TB with over the TC 02 or 01, and the BRD condition operational time of 2 minutes of 10 seconds for the EZ230K. TB is A in the A circle, meaning the braking torque with 3 Hz with 60 Hz. For meanings A, see figure 9.2. Motor convert motor kilowatts, inverter kilowatts. Moment and merit 1 motor kilogram metric squared meter squared. Rated torque of the motor, newtons of metrics. Motor torque E2, EZ2, 30K, 55K, 30, 50K, 55K, 110K. Table 2, you have the dynamic braking motor kilowatts, inverter motor inherit J on 1 motor kilogram motor metric meter squared. Rotor rated torque of the motor, newtons over meters, 50 Hz, 60 Hz. and motor torque ratio E2 and EZ2. Mean braking torque on one side is bigger capacity, standard combination motor, inverter braking torque, and limited with the overcurrent strength of the inverter. However, the increase of the rate of the inverter causes maximum torque of the motor. Figure 9.3 shows the braking torque of the inverters where whose capacity is increased by 1 motor capacity must be raised 135% more braking is required. Table 9.3 requirements of the maximized braking torque with more than inverter capacity is increased. Show the at mean brake torque at 135% to 1.35, increasing converting. Alright, hold on. Alright, sorry, I had something to do real quick. Alright, table 9.3 requirements maximizing braking torque motor, torque of the motor inverter capacity is increased by 1. Mean brake torque 135% of the torque is times 1.35. A increase for the inverter capacity by 1. Braking torque 0.5 by torque of the braking operation frequency. Other conditions same in the table 9.1 and 9.2. Motor kilowatts, inverter kilowatts, moment in merit J of the 1 motor kilogram and meter square rated torque of the 2 newtons of the meters, 50 and 60 hertz, and the number of set dynamic braking units, the E2 and EZ2. General use for estimation example, the calculates braking torque discharge resistance of the motor for the traveling machine rated motor torque as TM and Newton's time meters, which is 9,550 over rated capacity of the motor in kilowatts over rated revolutions per minute and RPMs. Braking torque required decelerated the motor torque newtons over the meters. Well, Newton's time meters value of the values negative. Only inverter can brake the motor. The BRD is not required. Reading braking torque is J times N1 minus N2 over 9.5 with the torque braking minus TL, which is load torque. J where equals moment of inerent mode load converted motor shaft kilograms over meters squared. N1 and N2 rotational speed RPM before deceleration, rotation speed RP after deceleration. TL load torque converted motor shaft newtons times meter. TB deceleration times seconds. Discharge resistance and Ohm resistance relative to the inverter if the value is under the minimum value of the BRD. 2 or more BRD is required. The resistance equal to the BRD opening voltage 362.5 volts for the 200 volt class, 725 volts for the 400 volt class over 0.4105 torque on a brake times the rotational speed of the RPM deceleration rotation speed after deceleration times 1 over 1.2. Mean discharge capacity, W capacity discharge unit should be 2.5 to 3 times the result of the formula. Discharge capacity 0.105 times torque of the brake times 0.2 times torque of the motor times the N1, N2, which is the rotational speed of the deceleration rotational speed, to over 2 times the torque of the brake times the torque of C, the capacity. Duty cycle, torque brake over 2 TC, the duty cycle on torque braking over 2 total torque capacity, charge, discharge, resistor following. Torque brake over torque C is 1/5 of the EZ230 Ks torque braking total capacity, or 1 to 10. The dynamic braking unit can be continuously used with the discharge resistor 2, see note 3 and N3, 4 over the capacity of the discharging resistor. See table 7 the one with the detailed discharging resistor 1 and 2. Thermal set value A is the square root of rated capacity discharge resistor over 2 divided by the rate resistance of the discharge resistor divided by 1.2. This reference value is the name of the ribbon resistor. Alright, 10. Maintenance and checks. Notice on maintenance and checks. Danger. Be sure to turn off the supply and power of the terminals positive and negative of the 45 volts or less. Make sure the default voltage between the positive and negative volts volts or less. Otherwise, you may receive serious electrical shock. Only authorized electricians are allowed to check and maintain and replace part of the dynamic braking unit. Take out all electrical medical accessories such as watch, jewelry before operating. Use insulated tools, otherwise you may receive serious electrical shock, personal injury. Note: always keep inside and outside dynamic braking unit clean. Always connect with the cables correctly. Miss from wrong connections are prohibited. Tighten the terminals and connecting firmly. Keep this device from wet, oil, dusted location, metallic filings. Can the product can easily short circuit the damaged unit and start a fire. Check items daily. Check periodic checks every 1 year. Insulation resistant testing, dielectrical strength. See page 25. Connect terminals as shown below with the test under the following conditions. Insulation resistant test measure the resistance between the ground and interconnect the terminals with a Magar. Make sure they're 5 mega ohms or more. Do not perform the dielectrical strength test when required. Apply with a 2000 volt AC between the ground and interconnect the terminals for 1 minute. Check for problems. Do not use any of the other terminals dielectrical strength test. Be sure to increase or decrease the test voltage slowly. Shift the Magar with the positive resistor and the negative of the result. Insulation resistant test of dielectrical strength. Voltage applied and through to the time to the right of the 1.10th of a second or more, and then it has a 1/10 of a second or more in the time, and then no time. All right, daily periodical checks. Check environmental. Check ambient temperature relative to the humidity concentration, dust, toxin, gas. Visually, audibly, but the ambient temperature should be 10 to 30, 50 degrees Celsius. Ambient relatively should be 20 to negative degrees. Non-condensing, abnormal vibration, none should be detected. Testing cool thermometer, hygrometer, multimeter. Device status, supply voltage. Check abnormal vibration noise of the device. Main circuit general insulation resistant test maybe the main circuit with the terminal ground terminal. Check with the loose screw, the terminal base. Check with the overheated burnt parts or cleaning. Checking method tightening screw firmly. Requirements no problem should be detected with tightening torques and the testing tools of 500 volt Magar. Terminal board check for the damaged brake with the visually and check methods. Requirement no problem should be detected. Smoothing capacitor PC board, check the electrical leak, check whether the capacitor is swollen, 1 and 2, visually, 1 and 2, no problem, should be detected. Requirement, 5 years on the typical replacement time. Resistor, check for the cracks and discolorization, check method visually, requirements, no problem, should be detected. Operation check for the sequence, protector check, just operation protective display, similarly output with inverter protection, testing check method. Requirement circuit should work normally. Control circuit, protective circuit, component checking, including PC board, general check with the burnt smell, discolorization, check for rust corrosion, check method individually, no problem should be detected. Requirement 5 years, typical replacement time. Circuit protective circuit component check, including PC board capacitor, 1 check the electrolyte leak caused deformation, checking method visually. The ambient temperature affects the surface life of the capacitor. See ambient temperature capacitor life of the appendix. 11. Parts and order and inquiry. Inquiry, ordering, replacement, provide following information for the hitch site, distributor, service, office, model number, the manufacturer number, symptom of the detail of the trouble in detail. If the label is hard to read, report with external view with appearance replacement part with a short explanation. Trouble to get with the ordering sheet. It is recommended you have another private auxiliary device you work will be disrupted. And then appendix, show the service life of the capacitor. Running time continuous 24 hours. Duty rate of 10% of the ED and the duty rate of 100% continuous regeneration. Ambient temperature, capacitor life fixture characteristics. Ambient temperature affects surface life with aluminum electrolyte capacitors. See appendix figure 1. Periodical check with the capacitor. Make sure free leaks, deformation, dynamic braking, and frequently the hot location capacitor will quickly deteriorate. Consequently, surface life with the dynamic braking unit may be shortened. And this has been a reading of the operation manual for the dynamic braking unit, a Hitch-Tight BRD series.